Welcome back. In this and the next lecture, we will address the following issue. Supposing you have a particular cell with a specific capacity. Supposing I want to get, let's say, twice the capacity, how should the cell be changed in order to meet twice the capacity is a question we would like to address. To answer that question, first we need to get an expression for the volume of the cell, which is what we would do in this lecture. To address this issue, we take a particular cell chemistry, even though this analysis is fairly general and applicable to many cell chemistry. Just for being more concrete, we choose a particular cell chemistry. In this case, it is lithium thionyl chloride cell. So let's first get a feel for the cell construction. The schematic is provided here. To understand the details, first we need to know what is the overall reaction that is occurring in lithium thionyl chloride cell. The overall reaction is lithium reacts with this component and forms lithium chloride, which is a solid, sulfur is a solid, and a gas is being generated. So where is lithium here? Lithium forms the negative electrode. One thing you ought to be noticing is in our earlier lectures on electrochemical systems, we were using anode and cathode. That is indicative of whether there is oxidation or reduction in the electrodes. Here in the battery literature, we are specifying the electrode as a negative electrode or a positive electrode. This is more in the electrical engineering sense. What is a positive or a negative electrode is determined by whether conventional current comes out of the electrode or into the electrode. So we would just use this terminology within the context of batteries. So this lithium is stored in terms of as a lithium negative electrode. So the entire lithium cannot get consumed because that if it gets consumed, there's nothing to conduct electrons. So over and above what is required for a given capacity, we have more lithium than what is needed. Then the solid components that are formed as a product of the reaction goes into the pores of a carbon material. Okay, so that forms the positive electrode. This is porous carbon. Within the pores are stored the products of the reaction. To separate the negative electrode from the positive electrode, you have a separator. So this is an electronic, that is electrical, it cannot conduct electrons. A separator is used to prevent shorting of the negative electrode and the positive electrode. In addition, there are current collectors that are connected to the positive electrode. This itself serves as a current collector for the negative electrode. And all these components are housed inside a cell can. Moving on, the volume of this particular cell is decomposed into different components. Here, V refers to volume and not voltage. The volume of the cell has contribution from the volume of the negative electrode, volume of the positive electrode, volume contribution from the separator, volume from the current collector, negative current collector, volume from the positive current collector. And in addition, because gases are formed in this cell chemistry, we need to have some excess volume to accommodate the gases that are formed because of the as a product of the reaction. So we'll first look at the volume of the negative electrode. So because the capacity is specified in terms of ampere hour, to convert that, you have this quantity 3600 to convert it into SI units. So this is the mass of lithium that is required to meet a specific capacity, because this forms in a way the current collector too. We cannot allow for the lithium to get exhausted. So over and above what is required for a particular capacity, you have some additional lithium that is given by this anode. A refers to anode design factor. So this is a term that is specifies the mass of lithium that is over and above, that is what is required for a specific capacity. The rest of it is just from Faraday's law, right? So this is the Faraday's constant, this is the density of a solid lithium. So the volume of solid products that is formed depends upon the mass of lithium chloride divided by this quantity, mass of sulfur divided by density of sulfur, and so on. This 4 comes from the stoichiometric coefficients. All the solid products goes into the porous carbon. So the volume of the positive electrode is determined by the volume of solid products that are formed divided by epsilon. That's refers to the porosity of carbon, times you need to have some excess pores over and above the pores that are utilized for accommodating the solid products. So that comes with the cathode design factor. So this is the overall thing. I mean, there should be another quantity. There's a typo here. FC should also be added. So in addition to this, there is the volume contribution from the separator that is given by the area of the separator. This is the separator that provides this component, this term, area of the separator, times the thickness of the separator, area of the separator times the current collector of the negative electrode, because the negative electrode is arranged in this manner. So the area of the negative electrode is more or less the same as the area of the separator. So this times this, the thickness of the negative electrode, gives you the volume contribution from the negative current collector. Because the positive current collector has only half the area of the separator, this times this quantity provides the volume contribution from the positive current collector. So the overall volume is sum of contributions from the different components. So you have component negative electrode, positive electrode, then there is this component Fx's that depends upon, that is used for specifying the volume requirement from the gases that are being evolved as a product. So again, that depends upon the capacity of the individual cell. These are the volume contributions from the separator and the current collectors. In the next lecture, we will look at the how do you use this formula, that is this volume formula, to think about scaling of capacity. What are the different options that are available to scale the capacity, and what are the trade-off associated with the different options? That will be taken up in the next lecture. Thank you.